Hi folks, this is Calc 2, Checkpoint Quiz 11. In this checkpoint quiz we're given some improper integrals to deal with. And so in part A here, the first thing we need to determine is this an improper integral, and if so, why? In this one, you notice that at the lower limit of integration 5, I get a 0 in the denominator. Okay, so that means that that's the limit of integration I have to replace in my limit statement. So I'm going to take the limit as b comes to 5 from the right hand side of the integral from b to 10, 1 over the square root x squared minus 25 dx. Okay, so I'm coming from 10 down to 5, so I'm coming into 5 from the right. So the first thing I need to do is determine this integral. So I can handle this using a secant substitution. I'll let x be 5 secant theta. And since I'm integrating from b to 10, where b is some number bigger than 5, I know that the angles that I'm getting here are going to be first quadrant angles. So the dx is going to be 5 secant theta tangent theta d theta. So when I do my substitution, I get the integral of 1 over the square root of x squared, which would be 25 secant squared theta minus 25 times 5 secant theta tangent theta d theta. Now we've been through enough trigonometric substitutions to know what's going to happen here. 25 secant squared theta minus 25 is 25 tangent squared theta. The square root of 25 is 5. That'll cancel that 5 out. And since I'm in quadrant 1, the square root of tangent squared is going to cancel out the tangent. So really I'm just left with the integral secant theta d theta, which I know is a natural log of the absolute value secant theta plus tangent theta plus c. And since I know theta is in quadrant 1, both of those values are going to be positive, so I don't really need the absolute value. Now to get things back in terms of x's, I go back to my substitution. X is 5 secant theta. That means the secant of theta is x over 5. And since I'm in quadrant 1, I know the tangent of theta is the square root of secant squared minus 1, which is going to give me the square root of x squared minus 25 over 5. All right, once again, we've done enough trig subs that this is standard practice at this point. So this becomes a natural log of x over 5 plus the square root of x squared minus 25 over 5 plus c. And once again, we can combine these into one fraction and then use a log property to get down to this. All right, or you may have just memorized this formula to begin with. In any case, now we go back. This is the limit as b goes to 5 from the right of this thing. Evaluated from x equals b to x equals 10. Alright, so let's go ahead. This is the limit as b goes to 5 from the right of, I plug 10 in here, I get the natural log of 10 plus the square root of 75 minus the natural log of 5 plus the square root of, not 5b, plus b squared minus 25. Alright, so let's see what happens here. As b comes into 5 from the right, that's got nothing to do with the b, so we'll leave that put for now. What happens inside here? b is coming into 5 from the right. So as b comes into 5 from the right, I'm plugging in numbers that are a little bit bigger than 5. So when I square them, I get numbers a little bit bigger than 25. So this is defined, and this is going to 0, and that's just going to 5. So I get minus natural log 5. All right, now if we simplify this a little bit further, I get the natural log of 10 plus, and 75, I can reduce that radical down to 5 radical 3 minus natural log of 5. And I can use log properties to rewrite this as 10 plus 5 radical 3 over 5, which is a natural log of 2 plus radical 3. And since I got a number out of this, I got a real number out of that. You might not be your favorite real number, but this limit did exist as this real number, and so we would say that the integral converges to that number. So that'll do it for part A. All right, in part B, we've got improprieties here at the limits of integration. They're both in infinite limit. So the way we handle this is we break this up at some convenient location, say 0, and we'll look at the integral from negative infinity to 0 of 1 over x squared plus 25 dx, and we'll look at the integral from 0 to infinity of 1 over x squared plus 25 dx. If each of these converge, then this will converge to the sum of these two numbers. If one of these should happen to diverge, then we'll say the whole thing diverges. So let's just look at the first integral from minus infinity to 0, 1 over x squared plus 25 dx. We're going to replace what's improper here with the limit, and in this case the lower limit is going to negative infinity of the integral from b to 0, 1 over x squared plus 25 dx. We recognize this as the arctangent. So this would be 1/5 arctangent x over 5 evaluated from x equals b to x equals 0. This gives us the limit as b goes off to negative infinity. Substitute in, I get 1/5 arctangent of 0 over 5 minus 1/5 arctangent b over 5. So this is the limit as b goes off to negative infinity. Arctangent of 0 is 0, so that zeroes out. I'm just left with negative 1/5 arctangent b over 5. Now, as b goes to negative infinity, the b over 5 goes to negative infinity, which means the arctangent of that goes to negative pi over 2. So this integral converges to negative 1/5 times negative pi over 2, which is pi over 10. Now, similarly, the integral from 0 to infinity of 1 over x squared plus 25 dx also converges to pi over 10. All right, the calculus is identical, except we have, instead of going from b to 0, we're going from 0 to b. So I put these two things together, hence the integral from minus infinity to infinity, 1 over x squared plus 25 dx, is the sum of these two, which is 2 pi over 10 or pi over 5. So once again, since we get a finite number, we say this integral converges. So that'll do it for part B.